guys, welcome once more to our YouTube channel. In today's video we are going to continue solving further math paper 1 questions of the Northwest Regional Mock 2022. So like you see, it is named part 2 because part 1 was done already. Part 1 was just the solutions to the first 10 questions. So part 2 we are going to solve from question 11 to question 23. So stay tuned. If you have not watched part 1, I'm going to include the video link to part 1 in the description so that you can click on it and you follow the first 10 solutions after following the 11 to the 23rd. Okay, so I think we can get started with the very first question, but before we get started, you can see on your screen some images. Now these images are just to alert the new viewers in this channel that there are interesting things in the channel. So after watching this video, you can navigate through the channel to see what you have missed so far. Alright, so let's begin with our very first question of today, which is question 11. Now question 11 came from the topic integration, and the question reads: a suitable substitution to use in evaluating the integral of 1 divided by the square root of 4x plus 9x squared dx is. You have been given the various options. Alright, so we are going to rewrite our integral as such: the integral of 1 over the square root of 2 squared plus 3x all squared, because 4 is the same as 2 squared and 9x squared is the same as 3x all squared. Now our main objective is to look for a certain substitution that is going to make this integral to be nice, because as it is like this, it is horrible, very difficult to integrate without a substitution. But using a substitution, we are going to find a way out, because we use a substitution to bring it to something that we can easily integrate standardly, and then when we integrate, we replace back our substitution to get what we want. Alright, so if you look at this integral, you see that for us to actually solve this integral, we need to remove this square root. That's the main idea. If we are able to remove the square root from here, then you're just integrating 1 over a certain function, a linear or any function is easy to integrate than when the square root is there. I think you agree with me in that light. So to remove this square root from here, then the interior, that is 2 squared plus 3x all squared, must be a perfect square, meaning that it must be something all squared, so that if you take the square root of it, you're going to get the absolute value of a certain function, because by definition the square root of a function all squared is the absolute value of that function. So if the function is positive in a certain interval, you just put the function itself. If the function is negative in maybe if you have an interval that you're integrating and you have the square root here, the square root of the function down here is not just going to be the function itself, it's going to depend on the limits of integration. If the function is positive in that interval, then the square root of the function squared will be the function. But if the function is negative in that interval, then the square root of the function square will be negative of the function. But in either case, we are going to remove the square. The square is going to remove the square root, and we are going to have plus or minus the function depending on the interval. So that is our main objective. Now how do we achieve this? In order to make 2 squared plus 3x all squared look like y squared, then our 3x here must be in function of 2. So our 3x will be 2 times a certain function, so that if we square both sides, you are going to have 2 squared, and then we can factor it out. This is what I'm saying, that 3x should be written as 2 times a certain function, and then if you square both sides, you have 3x all squared to be 2 squared times that function squared. So from there, if we substitute back 3x all squared into our original expression, we are going to get our original expression to be 2 squared plus 2 squared times a squared, because 3x all squared is 2 squared times a squared. Now from there, we factor out 2 squared and we get 2 squared into 1 plus a squared. Now we need to look for a certain function which is a, such that if we square that function and we add 1 to the function, then everything is going to give us a perfect square. So by some trigonometry identities, we know the initial identity cos squared x or cos squared u plus sin squared u is equal to 1. So at the end, you always have the third identity, which is 1 plus tan squared u is equal to sec squared u. So I see that if my a is equal to tan u, then 1 plus tan squared u will give me sec squared u, which is a perfect square. So definitely my a will be equal to tan u. It means my 3x will be equal to what? 2 times tan u, because my 3x was equal to 2a. So option A is correct. Okay, so we proceed with question 13. Sorry, there was no question 12 because the document that was sent to me containing the equations had no question 12. Question 12 was actually cropped out of the document. So if anyone has question 12, please you send the question to me. I'm going to put my WhatsApp number in the comment section as well as my email address, so that if you have question 12, you can just screenshot and you send it to me, so that when I'm going to be doing part 3 of these solutions, I'm going to begin with the question 12 itself. So without wasting much of your time, let's begin with question 13. It came from the topic forces and moments, and the question reads: the force F given by that acts through the position vector arrow. Now the objective is to find the moments of the force F about a certain position vector. So basically, maybe if you want to find the moment of a force having position vector arrow 0 about the origin, we just have the cross product of the position vector of the force and the force itself. Now in the case where the position vector of the force is given, and now you want to find the moment of the force about a certain point which is not the origin, how are you going to get it? It's simply the difference between the position vector of the force and the position vector of the points, and you do that, you take the vector product of that difference with the force itself, as you can see in red. So from there we begin by finding what arrow minus a is. It's just 2j minus k, because our arrow is 2j and our a is k. So from there we can look for our m, which is the cross product of the two. We begin with this guy here, so that's the first row is the coefficients of ij and k in arrow minus a, which is the coefficients of ij and k in 2j minus k. So the coefficient of I is 0, the coefficient of j is 2, the coefficient of k is -1. Now for the force, which is the second row, the coefficient of I is 3, the coefficient of j is 0, and the coefficient of k is 0. So if you do the cross product very well, you're going to get your m to be -3j minus 6k. So according to the responses, there was no answer. Alright, question 14 was on complex numbers, and the question reads: the cosine of pylon 5 plus I sine the pylon of pylon 5 all that raised to the power 20 is equal to, you have the various responses. So we are going to use the De Moivre's theorem. It says that if I take cosine of theta plus I sine theta and I raise it to the power n, is equivalent to the cosine of n theta plus I sine n theta. So in this case, we simply see that our n is 20 and our theta is pylon 5. It means this, I just multiply 20 times pylon 5, gives me 20 pylon 5. The same thing here. Now I simplify 20 pylon 5 is 4 pi, 20 pylon 5 is 4 pi. Now from there, cos 4 pi is 1, sin 4 pi is 0. So at the end we have z to the 1 plus 0i. So the correct response is A. Question 15 is in group theory, and the question reads: the order of the element 3 in the group, here's a group where the plus sign subscript 4 is addition in modulo 4. Now what's the element of, what's the order of an element? We are going to define it. It is simply the number of times you're going to compute that element with itself to get the identity element. Now we are going to give the composition of the table. So we compose each element with itself and then with other elements to have our table. So remember, this plus sign subscript 4 means addition in modulo 4. So you take the remainder when you add the two numbers and you divide by 4, you take the remainder. So doing that, you get this table. Now the order of the element 3 is the number of 3's that we are going to compose to have the identity element. But we need to find this identity element first before we find the number of 3's to compose. Now the identity element is simply an element that if you compose it with another element, it gives you that other element. So in this case, we see that the identity element is 0. because 0 plus in mode 4 of any element here it still gives you that very element plus in mode 4 of 0, which is that element. Like for example, 0 plus 0 operating with 0 is 0. 0 operating with 1 is 1, and 1 operating with 0 is 1. So you do the same for all the elements, you see that the identity element is 0. Now we see that word, our E is 0. Now we need to find the order of the element 3. So like I said, it is the number of 3s that you're going to compose to have back the identity element. So let's begin. If we take 3 and we compose it with 3, we are going to get 2. That's it. 3 composing with 3 gives us 2. Now we take the 2 and we compose it with 3 again. So taking 2 to compose with 3, we take 2 and we compose with 3, we get 1. And then we take 1 and we compose with 3 again. If we take 1 and you compose with 3, you get 0. So you stop there because you have arrived at the identity element. So finally we have 0. Now the order of the element 3 is the number of 3s that are involved in all these compositions. So we have 1, 2, 3, and 4. So there are 4 3s involved in this composition. Hence the order of the element 3 in this group is 4. So the correct answer is D. So we are going to continue with the next question, which is question 16. Now it came from the topic curve sketching, and the question reads: the center of symmetry of f of x equal to ln of x minus 4 divided by x plus 2 is. You have been given the various options A, B, C, and D. So I will go direct to the point, like that is what you are supposed to do whenever you're asked to find the center of symmetry of line functions. So basically, whenever you're asked to find the center of symmetries of line functions, you just look for the asymptotes and then you take the intersection points of the asymptotes. So basically, the center of symmetry of this function is the point of intersection of its vertical and horizontal asymptote, specifically the midpoint of the points of intersection, because you're going to have more than one vertical asymptote. So generally, the center of symmetry of functions like this is just a point of intersection of the vertical and the horizontal asymptote. But in the case where we have more than one intersection, you're going to take the midpoint of all the intersection points. So in this case, you are going to see that we have 2 vertical asymptotes and 1 horizontal asymptote. So they intersect at 2 points. So the center of symmetry is the midpoint of those 2 points. So now, since we know how to find the center of symmetry of curves like this, we need now to find those asymptotes. And to find the asymptotes, we need the domain of definition of the function, because from the domain of definition of the function, we can find the limits and the bounds, and from there we can deduce the asymptotes by their definitions. So for the line function to exist, the interior should be positive, and for this interior to exist, the denominator should be different from 0. So for the interior to be positive, you solve this inequality, and now for the denominator different from 0, you get x different from -2. If you solve keenly, you're going to get the domain of definition of the function to look like this. Now we need to take the limits at the boundaries or the extremities of the domain. So the limit as x tends to -2 from below of my function is positive infinity. Next, the limit as x tends to 4 from above is positive infinity. Next, the limit as x tends to -infinity is 0, and the limit as x tends to positive infinity is also 0. So by deduction, we can say that the vertical asymptotes are the lines x equal to -2 and x equal to 4, because by its definition, if you take the limit as x is tending to a certain constant, say a0, from below or above, and gives you plus or minus infinity, then that a0 is the vertical asymptote. Here we have our a0 to be -2 and to be 4, because the limits are given plus infinity and plus infinity. So x equal to -2 and x equal to 4 are the vertical asymptotes. Now the horizontal asymptotes are just found by looking for the limits at plus or minus infinity. So the limit at -infinity is 0, so 0 is a horizontal asymptote. The limit at positive infinity is 0, so 0 is also a horizontal asymptote. So definitely we have a unique horizontal asymptote. If the two values were different and were real numbers, then you're going to have 2 different horizontal asymptotes. But since the two have the same value, then the horizontal asymptote is unique. So we have identified the vertical and the horizontal asymptotes of my function f of x. Now where do they intersect? At the point -2, 0, when x is -2, y is 0, and then when x is 4, y is 0, so they intersect at these 2 points. Now my center of symmetry is going to be the midpoint of these 2 points because there is more than one point of intersection. So my center of symmetry, how do I find the midpoint between 2 points? I add their x coordinates, I divide by 2, I add their y coordinates, I divide by 2. From there I get the center of symmetry to be 1, 0 and not negative 1, 0. So here is supposed to be positive 1. So let's take note. Alright, so doing that, you see the response is A. As easy as that. Now let's go to question 17. It came from the topic probability, and the question reads: the probability distribution table from a discrete random variable y is given below. The mode of y is, so solution, let's define what the mode of a discrete random variable, let's say y is. So the mode of a discrete random variable y is just the value of small y such that p of capital Y equal to small y is maximum. So here is the table, here is capital Y, and then here is p of capital Y equal to small y. Small y is 1, 2, 3, and the small y represents integers. So small y there is in the set of positive integers, that is natural numbers. So the mode is just the value of capital Y such that this guy here is maximum. So I just come and look for where this guy here is maximum, and I take the corresponding value of capital Y. It gives me the mode of my discrete random variable capital Y. So I have 0.2, 0.4, 0.3 and 0.1. So I see it is maximum at 0.4, and the corresponding value of capital Y is 2. So it means that the mode of my probability, the mode of my discrete random variable capital Y is 2. So the correct answer is B. Alright, the question 18, it came in the topic functions, and it reads: the value of the greatest integer of 3.5 minus the greatest integer of negative 5.3, where this is the greatest integer function is. Now the greatest integer function is simply a certain function, let's say x, that is less than or equal to x. So this greatest integer here, that's this here, is simply a certain value that is less than or equal to this x inside here, an integer, the smallest integer that is less than or equal to x here. Now let's demonstrate. If I have this set, so we are going to look for the greatest integer of 3.5, and we are going to look for the greatest integer of negative 5.3. Now negative 5.3 is between negative 6 and negative 5. Now the greatest integer of negative 5.3 now is a certain number that is a certain integer that is strictly less than, that's the smallest integer that is less than negative 5.3, sorry. So the greatest, I'll repeat again, the greatest integer of negative 5.3 is the smallest integer that is less than negative 5.3, and it is negative 6, because negative 5 is greater than negative 5.3, but negative 6 is the smallest integer that is less than negative 5.3. So the greatest integer of negative 5.3 is negative 6. Next, the greatest integer of 3.5. 3.5 is between 3 and 4. So it is a certain integer, it is the smallest integer that is less than 3.5. And since 3.5 is between 3 and 4, the smallest integer that is less than 3.5 is 3. Integers are positive and negative whole numbers. So the smallest integer less than 3.5 is 3. It means the greatest integer of 3.5 is equal to 3. So with that, we can say the greatest integer of 3.5 is 3, and the greatest integer of negative 5.3 is negative 6. So the difference between them is 3 minus negative 6, which is going to give us 9. So the correct response is C. Now question 19 was in motion in 2 dimensions, and the question reads: a particle moves in a plane such that its polar coordinate after t seconds is given by r is equal to t squared, theta is equal to 3t. The transverse acceleration of a particle after 2 seconds is, we have been given the options A, B, C, and D. So first we define how to find the transverse component of the acceleration, and then we look for the various components and we substitute. So there we can find r, which is t squared. We can find theta dot dot, which is the second derivative of the angular velocity with respect to time. Now you have 2 times r dot is the first derivative of the r with respect to time, and the theta dot is just the angular velocity, that's the derivative of the angle. So we need to find the missing terms. We have arrow already, which is t squared. So we need theta dot dot, and we need arrow dot, and we need theta dot. So let's begin with arrow being t squared. It means arrow dot is just 2t, because I'm differentiating t squared with respect to t. So I have 2t. Now we have been given theta as 3t. It means theta dot is 3, differentiating 3t with respect to t. So theta dot dot differentiating theta dot with respect to t, we have 0, because theta dot is a constant. So with that, we get the transverse component of the acceleration as arrow theta dot dot. Theta dot dot is 0, so this just gives us 0, though arrow is t squared, plus 2 times arrow dot is 2t and theta dot is 3. Doing that, we get 12t. Then we have to find this transverse component after 2 seconds. It means after 2 seconds, our a2 by replacing t with 2 is just 12 times 2, which is 24. So the correct response is D. Alright, let's move on to question 20. It came in the topic called vectors. The question reads, the angle between the vectors j and j minus k is. So I'll just give you a brief description of the angle between two vectors a and b. So the angle between two vectors a and b is given by the formula cos theta. The angle between the vectors is theta. Cos theta is equal to the dot product divided by the product of their magnitude. So in this case, we just need to look for the dot product of the two vectors. So I'm going to write the vector j in the column form as 0, 1, 0, because the I component is 0 and the j and the k component is 0. The j component is 1. That's the coefficient. Now j minus k, the I component is 0, j is 1, and k is negative 1, divided by the product of their magnitudes. The magnitude of the vector is just the sum of the squares, the square root of the sum of the squares of the coefficients of the unit vectors present. So for j, since it's a unit vector, the magnitude is 1, which is the same as the square root of 1. Now for this, we have the square root of 1 squared plus negative 1 all squared, which is the square root of 2. So the dot product of two vectors, we just multiply the I, the j, and the k components, and we add together. So 0 times 0 is 0, plus 1 times 1 is 1, plus 0 times negative 1 is 0. At the end, we get 1 divided by root 1 is 1 times root 2 is root 2. So we have our cos theta to be 1 on root 2. Now we look for the principal value, meaning theta is just cos inverse of 1 on root 2, which is pi ln 4 or 45 degrees. So our correct answer is C. So question 21, I abbreviated simple harmonic motion. The question reads, the period of a compound pendulum is given by this. The length of the equivalent simple pendulum is. So the period of the simple pendulum L with length L is simply expressed as t is equal to 2 pi with L on G. So that's how we find the period of the simple pendulum. Now in this case, we have been given the period of a compound pendulum, but now we want to find the length of the equivalent simple pendulum. It means that the periods are going to be the same. So with that, it means 2 pi with L on G, G's acceleration due to gravity, is equal to this period here, which is pi ln 2 times the square root of 7a on G. If we square both sides, or pi cancels, we multiply by 2 here, we have 4. So we have 4 times root L on G is equal to root 7a on G. We square both sides and we are going to get L as 7a divided by 16. So the correct answer is D. Alright, question 22, it came from series, specifically the Taylor series expansion at 0, that is the Maclaurin series expansion though. The question reads, if x is small enough for x cubed and higher powers to be neglected, then e raised to the power 3x plus e raised to the power negative 3x approximates to, we have the various options. So first, we are going to identify e raised to the power 3x plus e raised to the power negative 3x as 2 cosh 3x. Why? Because cosh 3x is simply this quantity divided by 2. It means that this quantity is 2 times cosh 3x. Now, considering the Maclaurin series expansion as x approaches 0, we are going to we have the expansion of cosh x, that is capital X, to be 1 plus x squared on 2 plus other terms, since we are neglecting higher powers of x and the terms in x cubed. So with that, maybe if we take x now, capital X to be 3x, we can get 2 cosh 3x. We have the 2 outside, we have our 1 there, plus in the place of capital X I fit 3x, because this 2 cosh 3x is the equivalent. So finding this is the same as finding this, a very short method. So from there we get 1 plus 3x all squared divided by 2, which is going to give us 1 plus 9x squared. But since 2 cosh 3x is the same as e raised to the power 3x plus e raised to the power negative 3x, then we get that sum as 2 plus 9x squared. So the correct answer is option A. Now question 23, which is our last question, is on simple harmonic motion still. The question reads, if a particle moves along a straight line OX such that its displacement from O at time t is given by this equation, then its period of motion is, we have option A, option B, option C, and option D. So first we are going to find the general solution of this differential equation. But to find the general solution, we begin by finding the auxiliary equation. So the auxiliary equation, we are going to let maybe the parameter to be m. We have 25m squared plus 4 is equal to 0. So doing that, we have m is equal to plus or minus 2.5i. Now from there we can get the general solution as x, because it is in terms of x. So here is supposed to be dx by dt and not dy by dx. So d squared x by dt squared. So we should take note of this mistake here when I was typing the equation. So our x is going to be a, which is a constant, the cosine of omega t plus lambda. Yeah, that is m, which is 2.5. So doing that, you have your x to be a cos 2.5t plus lambda. Now we need a period, and if you compare this, you know period is equal to 2 pi of omega for sinusoidal functions. So comparing x equal to r cos omega t plus lambda means omega is equal to 2 feet, as you can see. So it therefore means that our period is equal to 2 pi divided by 2 feet, which is the same as 2 pi divided by 2 times 5, which is giving us 5 pi. So the correct answer is option D. So that was that for this part 2. We have solved from question 11 right up to question 23, though we never had question 12. So like I said earlier, those who have a question 12, you send it to me, so that in part 3 of the solutions, I am going to begin with question 12 before beginning the real questions of part 3. So make sure you like the video, you share the video with your friends, you subscribe to the channel if you